Hi, my name is Amy Bowling, and this is my lesson plan on how calculus students can design a pool based off of learning integration. So this is created for high school students in calculus. This is a project that will take place in the second semester after they learn about definite integrals. The driving question is that the students have been hired by the Ritz-Carlton to design a pool for their future hotel located here in Nashville, Tennessee. They want to send the students to send them a video presentation of their pool design and why the students' design should be picked. Kind of an overview is the students must design a pool using calculus. They have to determine the optimal size and layout of the pool that they wish to install. They need to determine how much the pool is going to cost to build and what is the maximum number of adult swimmers that can be in the pool at one time. But in general, overall, they need to summarize why their design is better than everyone else's, which kind of brings it back to style and layout. This is kind of the layout that the students would receive when we start doing the assignment. So it has an overview of the constraints that they'll have to consider when making their design. They have to consider some space limitations and adult swimmers, and there needs to be at least 2 entrances and exits to the pool, and just kind of more broken down details for that. So kind of the overall goals and standards of this project is students will be able to solve using optimization. They can calculate area and volume using definite integrals, and students will be able to apply definite integrals to problem solve with area and volume. Some technology standards that they're going to hit, we are going to be using a variety of technologies to come up with the solutions to their problem. They're going to be developing and employing strategies to solve the problem. Students are going to be communicating clearly and expressing themselves with their video presentation. Students will be using digital tools to broaden their perspectives. They're going to be researching different types of pools. They're going to have to present this and create their pool digitally and look at a lot of experience learning how to use different apps through that. Voice and choice. So students are going to be given a chance to choose what size and shape of pool they want. Once they decide kind of the footprint, because there's a couple different types of footprints that we learned about in calculus. So I'm going to let them pick which of those 4 options they want to choose. And then I'm going to assign them in groups based off of that choice. As they were working, once they get their groups assigned, they really can design whatever size, shape, style of pool they so choose. And they can choose, concrete, fiberglass, whatever they want as a base, but they do have to research it and figure out cost efficiency of that. The students will also create a 5 to 7 minute video that they will be, selling their design to the Ritz-Carlton, so they can put whatever they want in their video as long as they touch all the constraints and all of the requirements. They can kind of make it whatever they want. It can be like a commercial, it can be more official. They really have a lot of choice in what that looks like. Some of the requirements that I mentioned a second ago. So they need to delegate tasks among different members. So they're going to divide that out to make sure everyone has different jobs that they're going to be working on. They have to, towards the beginning, determine the type of pool they want to use. They have to make a rough design of the pool, and then they're going to have to create a digital final design of the pool. After they come up with the actual design, they have to calculate the volume, of the pool, and then determine cost. So they have to figure out the cost of building the pool and then filling it with water based off of the volume of the pool. And then they have to determine, once they have all that decided, they can figure out how many adult swimmers can be in the pool at one time, what is the maximum number there. And last but not least, they'll create a video presenting all of their hard work. This is going to be my rubric that I use to grade their presentations. I'll include this to this assignment for you to see, but it kind of breaks it down. It shows the students what to expect and what they need in order to get full credit. This is a group progress checklist, so this is what I'm going to be walking around with every day. It has all of the different requirements that they need to get done, organized kind of in the order that they will do them. So starting at the top, they'll delegate tasks. So they'll have all the different team names written and then mark them off once they get through those different tasks and requirements. And so they'll be able to see where they stand, and they'll be able to see where the rest of the group stands. So if they're behind the rest of the class, they'll know it. If they're ahead, they'll know it. And so this will just help make sure that everyone's on track. And then specifically, the final design of the pool is due Friday. So they know that that halfway point has to be met. So they can get a couple tasks done in one day. They can work ahead or spend more time working on one task as long as they get it all done by Friday and then the following week as well. So kind of going through day by day of this project, we start with day one. So students are kind of going to get a review of some of the definite integral stuff we've already talked about. We're going to look at some online tutorials to review problems of finding area of volume. They will have already learned that, but we need to go back over it and just make sure that they understand kind of in the thought of designing a pool, because they definitely need to be designing it in a way that they can solve it with calculus. They can't just draw it out willy-nilly and think they can do it. They definitely need to do it with calculus in mind. So we'll be going back over some of those questions online. We'll have a class conversation about misconceptions as they were solving and kind of what they think about pools. Like, do they think there's any constraints, or is there any easier designs than others that they could use after finding these volumes, kind of morphing the two, getting them brainstorming about things at the beginning. I'm going to record a video for the students that describe everything they need to know about the project. So then if any students are absent or if they want to refer back to it later, it's really easy for them to find and to watch. So I will show that for the whole class, but I'll also send out the link for them to kind of see me doing what I'm doing right now, presenting what they need to know about the project. So after I present the project, I'm going to ask them to give me their choice of footprint or general layout of the pool. That's how I will divide people into groups. I won't tell them that at the time, obviously, or else they'll pick the same as their friends. But this will be just a good way to split up people and give them a little bit of choice in what they design. Before they leave class, they'll complete an exit ticket of just setting up 3 different integrals, trying to find the volume and shapes with different cross sections, just to make sure that they're able to do them all. That's just a quick little check for understanding at the end of class. Okay, so now more broad, days 2 through 4. So days 2, I will go ahead and assign them groups, and they will need to get a rough draft and start estimating volumes with calculus. Day 3, they're going to delegate tasks. Using the Scrummy app, students will begin researching different types of pool designs. Now that they kind of have a general understanding, they've played around with a couple different designs, they can actually put their feet on the ground and start running. Day 3. Day 4, they're going to continue to research pools and pick a rough design for their pool. They will have to determine the different cost of materials and pools and the pros and cons of each. On day 5, I kind of already mentioned that is going to be the day that their design is due. So that's going to be more of a formative assessment. I'm going to check in with each group. They're going to rotate through a stations with me, and they need to have their final design and building materials decided, and that's when they'll start thinking about cost and the calculus of it. But they need to have some sort of final design by that Friday. So the next week, days 6 through 8, they're going to have to finish finding the volume of the pool, try at least 3 different methods of approximation to see what types of numbers they get, if they're close off, if they're all pretty similar. You know, are they doing the calculus right? Are they doing it wrong? We want to kind of make sure that they've done it a couple of different ways to make sure that they're getting the same number each time. Something I put on there, all mathematical thinking needs to be presented in their final presentation video. So that's something that I'm going to be working on with them is writing out their steps, showing their work in a way that everyone can see it, even someone that maybe doesn't understand calculus, trying to make their thinking legible and understandable. So day 7, they're going to actually calculate the volume and optimization cost of the water. If they have not set it up yet, they should begin working on the presentation video. In day 8, students will finalize all of their work into one presentation. If they haven't already started that, that's kind of the day that they need to be finishing it, but most of that day will be spent working on those presentations. So day 9, they will actually show their videos to the class and kind of get to talk about it. And the class, as they're showing videos, they'll have comment cards to be filling out, positives and suggestions for the groups as they watch other people's videos. And day 10, we'll have a reflection conversation as a whole class. What went well, what could have been different, what did they find when they were trying to find the volume of the different pools? Was there something that was an easier shape than another? Were there any shapes they weren't able to find the volume of? And we might wrestle with those together as a class. When they finish their videos, they present them in class. The public audience, I'm going to have them added to our parent bulletin that will get sent out to parents and teachers, so everyone can see their videos. They'll be posted on the school website so that anyone else that wants to come across it, maybe in Googling search or whatnot, will come across their videos and see it. In general, that's the overview of my calculus project to design a pool. I'm really excited for them to do it and to see how it works. I think it's something that the kids will really get engaged in and get excited about, and so I will let you know how it goes once I do it. Thank you.